So this video is going to review the worksheet that you did in class today. Question number 1. An Olympic-sized swimming pool is about 50 meters long. If there are about 3 centimeters in a foot, about how many feet long is the pool? And we're going to round to the nearest foot. So when we are comparing two different things, we're going to create a proportion. And to help us out, I like to use a one chart so we can make sure that we have our proportion lined up correctly. In this case, we're comparing meters and feet. In my O, or my original column, I'm going to put what I know for sure. I know for sure that there are 3/10 meter and 1 foot. In my new column, I'm putting what I need to figure out. So I know I have 50 meters long for the swimming pool, but I don't know how many feet that is. So let's go ahead and solve our proportion. Like always, go ahead and cross multiply. So 1 times 50 is 50. And then divide by 3/10 to give you x. And that's going to give you 166 and 6/10 repeating feet. But if we round that to the nearest foot, that is 167 feet. So whenever you're comparing two things, go ahead and make a one chart, create a proportion, cross multiply, and divide. Number 2, Elena's car will hold 12 gallons of gas. There are approximately 3.78 or 3 7/800 liter in a gallon. So how many liters will Elena's car hold? So once again, we're comparing two different things. So if you want, you can use your one chart. For this one, we're comparing liters and gallons. I know for sure that there are 3 7/800 liter in 1 gallon, but I do not know how many liters are in 12 gallons. In this case, we're just going to multiply 12 and 3 7/800, and you should get 45 and 3600 liters. For number 3, triangle ABC is similar to triangle DEF. Which side of DEF corresponds with side AB? So if you remember, we went over similar figures and congruent angles and all of that. I told y'all to line up the sides of your triangle like this. So this lets you know that AB corresponds with DE. So AB will correspond with this right here, okay? Number 4, triangle ABC is similar to XYZ. Which angle in triangle XYZ measures 37 degrees? So for this one, just take a look at it. We're just looking at angles. Triangle ABC and triangle XYZ are flipped, kind of like a mirror image. As you can see, we have our 90-degree notation here. 37 degrees is right next to it, adjacent to it. So that means this is the angle that measures 37 degrees in triangle XYZ. And remember, in order for figures to be similar, they are the same shape but different sizes, and the angles are congruent. The angles are equal, and the sides are proportionate. Number 5, if the triangles below are similar figures, what is the value of y? So a little different here. We've never seen one with 2 variables on it, but it's still the same way that we solve it. So I'm going to use corresponding sides. Side 12 corresponds with side 6, and side 13 corresponds with side y. Create your proportion. 12 over 13 equals 6 over y. Multiply 13 times 6 is 78, and then divide that by 12 to get y. And when you do that, you will get 6.5. Number 6, triangle YAB is similar to triangle YHV. What is the length of side YH? So this looks like one we've seen before. We have a smaller triangle here, and we have a bigger triangle on the outside. For my smaller triangle, my sides are 17 and 16, and that's equal to x, because I do not know this side on my bigger triangle, and my other side is going to be this whole thing down here, so 16 plus 22, which is 38. Once again, cross multiply. 38 times 17 is 646. Divide that by 16 to give you x, and we're going to have a decimal here. X is equal to 40 and 375 thousandths. Number 7, The express lane at Mighty Mart is for purchases of up to 10 items. If Marcia is buying 4 items, which inequality represents how many items each of her 3 children can select and still go through the express lane? So we're going to write an inequality. First, let's figure out our M, or our rate of change. Remember, your key words for M are each, every, and per. In this case, it's each. So M is going to be 3. Our initial value, or whatever she's starting off with, is 4. She's buying 4 items. Now this is an inequality, so we have to figure out which inequality symbol to use. My keywords for that is up to 10 items. So I can buy 10 items. I can buy less than 10 items, but I can't buy more than 10 items. So that's going to be less than or equal to. So our inequality is going to be less than or equal to 12. Our rate of change was 3, so 3x. Then my initial value is 4, so plus 4. 3x plus 4 is less than or equal to 10, and A is our answer. We're going to skip number 8 because I printed off the wrong way, so there's no number line to match with inequality, so skip number 8. For number 9, find the value of x in the equation modeled below. So our equation is 3x minus 2 is less than or equal to 1. We'll go ahead and solve. I'm going to add 2 on both sides. But before we solve, let's backtrack a little bit because I forgot the golden rule. So does my golden rule apply here? It does not, because my coefficient is positive, not negative, right? So I do not have to flip my sign. The golden rule does not apply. So now let's solve. Add 2 on both sides. 3x is less than 3. Divide by 3 on both sides, and x is less than 1. Number 10. Which inequality below represents the solution set for the inequality negative 3x plus 4 is greater than negative 2? So remember, anytime you have an inequality, your first step is to look for the golden rule. Does my golden rule apply here? Yes, it does. My coefficient is negative, so I need to go ahead and flip my inequality sign. So instead of greater than, I'm going to have less than. I'm going to subtract 4 from both sides. So negative 3x is less than negative 2 minus 4. Remember, when you have the same sign, you add and then keep the sign. So it's going to be a negative 6. Then divide by a negative 3. A negative divided by a negative is a positive. Same sign positive, different sign negative when you're multiplying and dividing. So x is going to be less than 2. So our answer here is B. Number 11. A health club charges a $50 initial fee plus $20 for each visit. Bob has budgeted $150 a month to the health club. The inequality 20x plus 50 is less than or equal to 150, where x is the number of visits, represents the solution. This situation. Will Bob be able to visit the health club once a week during the month if there are 4 weeks in 1 month? So for this one, we're just going to solve and see if it makes sense. So let's look at A. Yes, because 20 times 40 plus 50 is less than or equal to 150. So according to order of operations, I need to first, or 20 times 4, I need to first multiply 20 times 4, which is 80. So now I have 80 plus 50 is less than or equal to 150. And 80 plus 50 is 130. And 130 is in fact less than or equal to 150. So A is our correct answer. B doesn't make sense because that's not the right inequality. C also does not make sense because they flipped the sign, and then D doesn't make sense. So A is our correct answer here. Number 12. Felicia earned $800 a month. The table shows her monthly budget. Which of these statements is supported by the table? So for these type of problems, whenever you have a budget table and percents and numbers, go ahead and figure out your percent of your number, your part of your number. So let's look at F. Felicia spends 10% of her monthly budget on clothes and food. So I want to take my $800 a month, and I want to figure out what 10% of that is. Remember, when we're working with percents, we always change it into a decimal and then multiply. When I multiply 800 times 10%, or as a decimal, 10 hundredths, it's going to give me 80. So this is saying Felicia spends $80 of her monthly budget on clothes and food. Let's look at clothes and food. Clothes is 50, food is 100. That makes 150. So does she spend 150 on clothes and food? Nope. Or does she spend 80 on clothes and food? No, she spends 150. So F is the incorrect answer. Look at G. She spends 50% on car payment and cell phone. Let's figure out what 50% of 800 is by changing 50% to a decimal and then multiplying. 800 times 50 hundredths is going to give me 400. Let's look at car payment and cell phone. Car payment is $275. Cell phone is $125. 275 plus 125 is 400. So does Felicia spend 400 on car payment and cell phone? Yes, she does. So that's our correct answer. Just to double check, 25% of 800 is 200. She spends more than 200 on her car payment, so it's on H. And then 20% of 800 is 160. And she spends 200 on college savings, so 200 is more than 160. So J is also incorrect. The model below represents an equation. 1x plus 4 is equal to negative 1x minus 6. So here we have an equation with variables on both sides. We still box and circle to help us out. Now, for this one, this is a multi-step equation. So our first step is to get all the variables on one side and to get all the constants on one side. So I'm going to take this negative 1x over here, and I want to move it over here to this side. But you always do the opposite whenever you cross over the equal sign. So instead of a negative 1x, I'm going to do a positive 1x on both sides. So this cancels out, and I have 2x plus 4 is equal to negative 6. Now we have a good old two-step equation. Let me rewrite it so I have extra space. So 2x plus 4 is equal to negative 6. Still boxed and circled. Get rid of your constant by subtracting 4. Always do the opposite. So 2x is equal to negative 6 minus 4. I have two negatives, so I'm going to add them up, but keep them a negative. 6 plus 4 is 10. So we have negative 6 plus negative 4 is negative 10. And lastly, divide by 2 on both sides. A negative divided by a positive is a negative, so x equals negative 5. Number 14. 2 bike rental companies rent bicycles so that students can borrow and ride to the park or to school. One company, Wheels on Fire Rental Bike, charged an initial fee of $12 plus an additional $3 per day to rent a bicycle. The other company, Really Good Rental Bike, charges an initial fee of $20 plus an additional $1 per day. Which equation could be used to find D, the number of days each student needs to rent a bicycle so that the total cost could be the same for both companies? So we're going to write an equation with variables on both sides. So what I'm going to do is I'm going to write Wheels on Fire on one side and make it equal to Willie Good on the other side. So let's look at Wheels on Fire. Remember your rate of change, your keywords are each, every, and per. So for Wheels on Fire is $3 per day. So 3, I'm going to use D for my variable. And then my initial fee of $12. So that's what I'm starting off with no matter what. And then for Willie Good, $1 per day. So 1D. Initial fee of $20 plus 20. So let's look at which one matches our equation the closest. F is 12 plus 3D, which matches up with this, is equal to 20 plus D. So remember, 1D and D are the same thing. Whenever you have a variable, there's an imaginary 1 in front of it, okay? And so that matches up there, so F is our correct answer. G has your coefficients and constants mixed up. Same for H, and then J just doesn't make sense at all. So F is our correct answer. Number 15. Which number is closest to the square root of 123? Let's take it way back to the beginning of the school year when we talked about irrational numbers and approximating irrational numbers. Whenever you have a square root, you want to figure out which two perfect squares it falls in between. So for 123, the square root of 123, That falls in between the square root of 121 and the square root of 144. Those are my perfect squares. The square root of 121 is 11. The square root of 144 is 12. So where would the square root of 123 fall in between? It would fall closer to 121. It's closer to 121 than 144. So it would fall closest to the number 11. So G is our correct answer there. Number 16. Samantha used a table to describe some numbers. How should she fix the table? So we have a table here. We have our numbers and the classification. So 258 thousandths is real and rational, but it's not irrational because it ends. Remember, irrational numbers are non-terminating decimals. So because this stops, that is a rational number. The square root of 2 is irrational, but it's missing one. Remember that all of our numbers are real. So that's our answer there. It should be G. The square root of 2 should also be a real number. It's not a rational number, and it is an irrational number, so it's already there. And we said that 258 thousandths is a rational number, so that's also incorrect. So our correct answer is square root of 2 should also be a real number. Number 17, which of the following sets shows the numbers ordered from greatest to least? Greatest to least. Make sure you read these questions carefully so you know what order you're going in. Whenever you have real numbers, change them into decimals if you can, okay? So first of all, we know that we're going from greatest to least, so a negative cannot be the first number. So A and D are crossed out. Now let's take a look at B. So I have the square root of 27 over 3. 27 divided by 3 is 9. So really all we're doing is find the square root of 9, which is 3. So it goes 3 and then negative square root of 5. That doesn't make sense because if we look over 2 times or 2 numbers, we have a positive square root. So that's definitely not from greatest to least. So it's not that one. That means it has to be C, which does make the most sense because it goes from positive to negative. So use some logic on your semester exam. If it doesn't make sense, cross it out. Number 18. Which choice below shows the following real numbers in order from least to greatest? So for this one, we're going from least to greatest, which means we're going to start off with a negative number, which eliminates some answer choices for us. It can't be H and it can't be J because those are positive numbers. For this one, we're going from negative to positive. Let's take a look. F, we have negative square root of 6. So going back to what we talked about with the irrational numbers, negative square root of 6 falls closest to negative square root of 4 and negative square root of 9, but closer to negative square root of 4. This is going to be, and I kind of cheated a little bit, which in 8th grade, y'all will get to use a calculator because negative square root of 6 and negative 22 over 9 are very, very close when we change it to a decimal. So negative square root of 6 is going to give us a negative 2 and 45 hundredths. And then if we divide negative 22 over 9, we get a negative 2 and 44 hundredths. So if we're going from least to greatest, that means F is our correct answer because negative 2 and 45 hundredths is least. Is lower than negative 2 and 44 hundredths if we're looking at the number line. So F is our correct answer here. Number 19. During migration, a butterfly can travel 30 miles in 1 hour. Which graph best represents Y, the number of miles a butterfly can travel in X hours? 30 miles in 1 hour is what we're looking for on our graph. So let's look at each graph and see which one makes sense. So F is saying 30 miles in 5 hours. That's not what we're looking for. Let's look at G. G is saying 30 miles in 1 hour. That's our correct answer. Let's double check. H is saying 30 hours and 5 miles. That doesn't make sense. And J is saying 30 hours and 1 mile. Also doesn't make sense because we're looking for 30 miles in 1 hour. So G is the correct answer. Number 20. Ashlyn and Alyssa sold baked goods for a school fundraiser. Ashlyn sold cookies at a fundraiser for 50 cents each and a cake for $14.50. Alyssa sold cookies for 75 cents each and a pie for $12.30. Write an equation that we use to find the number of cookies the girls could sell to make the same amount of money. So we're just writing an equation here, we're not solving. And let's do like we did with our bike rentals. We have Ashlyn on one side and we have Alyssa on the other side, and they're going to be equal to each other. Remember, when you're writing equations, M, or your rate of change, you can tell which one that is by the keywords per, each, and every. So for Ashlyn, her rate of change is 50 cents each, and then she sold a cake for $14.50 as well. Allie is selling cookies for 75 cents each and a pie for $12.30. And that is all we need to do for number 20. Just write an equation. Number 21. William has $40 and spends $150 every day. Wallace has $9 and saves $150 every day. Which equation can be used to determine when they have the same amount of money? Once again, we'll write an equation. William and Wallace. Very important to read your questions a few times before you start answering. So William has $40, so that's his initial value. But he spends $150 every day. So when you're spending money, you're taking away money. So I'm going to subtract $1.50 for every day. So that's my rate of change. Because remember, your keywords are per, each, and every. Wallace has $9 and he saves, so that's an additional amount, saves $150 every day. So I have 40 minus 150x is equal to 9 plus 150x. So my correct answer, the one that looks most like mine, is going to be A. Number 22. Jack and Jill purchased cell phones. Jack signed up for a plan that charges a fee of $24 each month plus 8 cents every minute he talks. Jill's plan charges a fee of $10 each month plus 15 cents every minute she talks. Which inequality could be used to determine when Jill's cell phone plan costs more than Jack's cell phone plan? So for this one, once again, we're writing an inequality. We're going to use more than, right? Because that's what we're trying to figure out when Jill has more, when hers is more. So we have Jack and Jill, and they went up the hill. Jill's is going to be more. So first of all, we have this inequality. Let's look at our answer choices. Which one's going to be crossed out? A and C. So Jack gets charged 8 cents every month, and then $24 as well for each month. Jill gets charged 15 cents each month and $10 as well. So there is your inequality, and the one that matches it is B.